our physics class, we were asked to come up with a project that pushed us in ways that we hadn't been pushed in school and also had some sort of practical application in the real world. And we called ours the motion-controlled robot arm. The purpose of our project was really just to explore robotics, engineering, and apply all the learning that we'd done in the physics classroom to a real-life scenario.
We took two pieces of technology. We took an accelerometer and a gyroscope, and we mounted them on a glove and used readings from both the accelerometer and gyroscope to control the motions of a small robot arm. The motions of the robot are controlled by 6 actions. So if you turn your hand right, the robot arm will shift right. If you turn it left, the robot will shift left. The second set is if you tilt your hand forward, the robot arm will go down. Tilt your hand back, the robot arm will go up. There's a button on the palm. If you press it down, it'll go out for as long as you hold it, and then the second time you hit it, it'll come in for as long as you hold it. The final motion is there's a button on the index finger that when pressed will open the claw, and when pressed again will release the claw.
I decided to do a lightsaber for my project because I'm a really big Star Wars fan, and I thought it would be really cool. So basically how it works is it runs from a power supply, the lightsaber. It runs from a battery, and through the battery it goes to a microprocessor, which you can change different. You can change the LEDs to different colors, any color you want on the rainbow, which is really cool. And through that, there's a coding aspect, which is a challenging yet really exciting, adaptable way that you can kind of customize your project, which I really enjoyed. And through that, it runs through an audio system, audio board, and out of a speaker, which gives you that well-known sound that everyone knows the lightsaber for. And it runs through an LED strip and lights up blue, which is the Jedi blue that everyone loves.
My project specifically was, I did it with Jason Cushman, another student here, and it was like a pocket EMP, which is basically a device right here that we built. You can kind of just like fire it at a calculator or something with pretty basic circuitry, and it'll turn it off temporarily.
For our project, myself and Jack Harwood, we made a pair of magnetic boots that allow users to strap in and sort of walk on the ceiling if it's made out of metal. So if you have a situation like in the blue gym at our school where it's a metal ceiling, it might be easier not to get a ladder if you're trying to do work up there, any sort of maintenance like change a light bulb or anything like that. This just allows users to strap these on, be in a relatively safe and stable environment because the magnets are strong enough to support up to 450 pounds and allow the user to do whatever they need to do.
For our second semester advanced physics project, Martha and I decided to make a digital and portable LED snake game, which was displayed on an 8x8 LED matrix.
This project was difficult and rewarding, and one of the reasons why we chose it and something that we learned from it was the relationship between code and hard-wired circuits.
We decided to create this project just because we knew that we would be working on it for a very long time, and in the end we wanted to come up with a product that we would be able to enjoy and, in this case, play the game.